Hello and welcome to Math Minecraft to Computers episode I12. This is Imroy and today we are talking about monostable circuit. Monostable means it's a circuit that wants to stay in one state or the other. So if it's a circuit that's off, it wants to stay off, and if it's a circuit that is on, it wants to stay on. But before we can actually start talking about the monostable circuit, the first thing we need to talk about is clocks. Now, if you recall, in the past, we built a clock over this region where we simply used blocks and torches. So let's build one of those real quickly. Again, the easiest way is to do a block. You have to remember you'll have a torch, and then you'll have redstone wire that looks like this. Torch on the side, redstone wire here. For every time that you do this, you will add more delay to the clock. So we're going to build a longer one here. I'm going to go there. Every 3. So you can see how I'm doing this. And then we'll do one more. We're going to cut over to here, so you have a torch of redstone, and then it'll be here. Now we just line them up. Come back to our beginning. And of course we have to make sure that we have an odd number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 right here. So now we just need to wire all this up. Let me get my wire, do the same thing. All of these. And now we're going to wire this one into this block. And the same thing here. Complete all of our wire. And then we'll bring a wire out there. We'll put a light there. Now to complete the circuit, I need to do this. And then we do our torches. So we'll start with the torch here. And then on every one of these blocks. This torch goes on the side, so we bring it over to this one, and then we go back by putting torches here. So as you remember, this actually creates a circuit, a clock. We actually have to bring this one more to here, and then we bring it over to this one. Put my light right here. And now you can see that this is going on and off at a rate. The pulse is always constantly running in this loop. And it comes back to here, and we've got it on and off. Now you see this is fairly reasonably stable here. On, off, on, and off. Now, if we were to shorten this, and I can do that simply by going to any one of these, we just block this off and that off. We can put our torch here and connect it here. Now you see that our pulse is shorter. So if you think about this being a powered state and unpowered, like this. Power on, power off, power on, power off, power on, power off. If you were thinking about what that would look like over time, what that is actually a graph. And that graph looks something like this. So you can see that we have a pulse that starts, and so we have along the bottom, if that is 0 voltage, and then suddenly it rises up to some other state. That's an up voltage situation. And then it comes back down, and then we have an unpowered, and it comes back up, and we have a powered. So it isn't down, up that we have. Now it's important in this because you think this is the pulse off, the pulse on, the pulse off, the pulse on, the pulse off. So that's what the clock does. It provides no power, or 0, and then a 1, and then a 0, and then a 1, and then a 0. And that continues on. Now in real electronics, it tends to look a little more like this. This shows you the actual voltages that could be So if this is a 1, 2, 3, 4, 5 volt clock, so it goes from 0 to 5 volts, you can see that it actually goes over almost up to 6, comes down, and it's not that steady. But this is actually what a real clock looks like. They can make these better to make them more square. But what ideally we are looking for is back to this clock. And then what you actually have is a clock period being this long. It starts here and it actually goes to here. That is the clock itself. And so what we end up having is a clock with a rising edge. That's this part here that comes up like this. And then you also have the actual pulse across, and then as it comes down, you have the falling edge. So that's the backside. So as it makes this look, we actually end up with that. Now this is a clock width. Now if you put this all together, you have the clock width being how long this is. You have a rising edge, and you have a falling edge. That means it's going from 0 to full power, which is the rising edge, and then it goes from whatever full power is back to 0. That's the falling edge. Now a whole period is starting from 1 coming up, where a rising edge comes up power, all the way to the next one. So a clock period is actually this long. That's how clocks work. Well, we can build a lot of these clocks that pulse like this, and we can control how they are by adding longer. The reality that we want is something a little bit easier to control. So we're going to do that by building a different clock. And we've shown this in a previous episode, but we'll go over it here. And this is called a 2-hopper clock. So I'm going to start by getting a hopper. Which looks like this. And you put one down, and then if you right click on this hopper opens and lets you put items in the hopper up here from my inventory. But what you do instead is you shift right click, and now you'll see that this hopper has actually connected to that. So what this hopper does is items put into here will go wherever they go this way. So delete this, face this way, hold down the shift again, and click. So now I have 2 hoppers pointing into each other. Now what's interesting about this is if I take any of my inventory and put it in this hopper, you can see that this item is moving back and forth, back and forth. Now the way we can actually use this is we're going to take another item, which is going to be a comparator. It's one that we haven't talked about yet in Redstone, but it looks like this. It is a triangle. And what we now need to do is point it away from the hopper. So you do that like this. You see that the triangle now points this way, and we do the same thing right there. Now what's interesting about this is you can put a light on either one of these. And what the comparator is saying is if there's a value in here, then it turns on. So since this hopper has something in it, this turns on. And since this hopper has something in it, virtually all the time, this one turns on. So that's how that works. We're going to get rid of these, and we're going to instead put a block there as part of our circuit. Then we're going to bring a piece of redstone here, and a piece of redstone here. Now what we need are sticky pistons. So I'm going to replace my hopper with a sticky piston. And once again, click here. And click right here. Now what I'm going to do is turn this power off, and in between these two, I'm going to put a redstone block. Looks just like this. Okay, now that I have the redstone block, I'm going to put this on. I want to go into my 2 hoppers. Well, that was not my intended action, but it's easy enough to replace. Simply get a hopper back. Shift click, and they're pointed into each other. Now I'm going to take this out as it builds up in here. And as as you hear it going back and forth. So the way this now works is I have no items in here, so neither comparator is on. So for the time being, I'm going to delete this block. If I put items in this one, it can be any item, but I'm just going to pick up, say maybe 6 of these and drop them in here. I'll put this block back and see what happens. Okay, so the items are moving back and forth between the hopper. It's in this hopper, then this hopper, this hopper, and this hopper. You can see the comparators change here depending on that. So the interesting thing about the hopper is when it gets empty, it powers. And so what's causing that is this gets empty, this comparator then, like a repeater, strongly powers this block, which fires this piston. And the same thing. Now to simply make this into a clock, I have to put some redstone here and put on my light. So there it is. Okay? So here comes the rising edge, and we're powered, the falling edge, and we're unpowered. The rising edge, we're powered, falling edge, we're unpowered, and the pulses are equal. The neat thing about this clock is, if I want it to be slower, I simply add more redstone. Or any item that you want in there. Now you can see the clock is slower. But the pulses stay the same. So I have the same amount of time off as I have on. Now, other thing that I can do to even make this particular clock better, I'm going to get my lever back. You can put a lever on the side of this. I'm going to turn this on. My clock will stop. So you see it stop. When I want to start it again, simply turn this on. Now, it always stops on the falling edge. So when I stop it, I'll stop it right here. And you'll see it'll slide back and stop on the falling edge. So this is actually a clock that we can start and stop. We can actually control. I'll take this half out, we'll restart it, and it will be much faster. And so that is the type of clock that we're using that'll give us our rising and falling pulses that you saw. So I'm going to put the clock up here in the left-hand corner, and you can see how this works. I'll show you the rising and the fall. Slow it down a little bit by putting maybe 3 in. Okay, so here we go. Rising edge and power. Falling edge unpowered. Rising edge and powered. Falling edge and unpowered. And that's how the clock works. Now, if you remember with the JK Flipflop that we built last time, one of the systems that we ran into all the way over on that particular situation was when we toggled the button, or the lever in this case, if I didn't do it fast enough, I got into situations like this. So you can see there, the circuit was bad, we had an issue. Now we have a problem where, oh, what do? I have to come in here and delete a wire somewhere and restart it. And so we had a problem with the button, as you recall. I want this to be a fast pulse, but the right amount. And once I was too fast, we run the same thing. If I get it just right, then the JK Flipflop toggles. You can see that can be difficult. If I turn it on, you can see that it just toggles all the time, back and forth. And there we are. It's another situation where it's bad. Gonna reset everything here. If I get it right, you see it toggled, but it toggled back. Oh, too fast. And so what we want to do is, it would be nice if we had some sort of circuit that said, well, I want that pulse to be exactly the right length. That would be called a monostable circuit. So in this case, it's an off circuit that wants to stay off. So if I give this a pulse, I want it to avoid this situation. So what I'm going to do is I'm going to go back to where we started and build our clock over here. Okay, so we want a JK Flipflop in this area that we want to test with. So I'm going to leave that clock for now, and what we're going to go to is we're going to go back to our JK Flipflop. Remember this one, we got the timing down to a point where our button can work to a degree. But as you can see, that was at both lights. It flips a couple times. Toggle, 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 and it finally settles. And it does toggle for us, but too many times. So that if we actually had a circuit that needed output from this, that would be a problem. Instead, we're going to use this one, which, as you recall, this uses the two AND gates and the two NOR gates. What we're going to do, I'm going to show you how to actually copy this stuff fairly easy. We're going to line up, we're going to mark the corners. I'm going to go right here, and I'm going to put a different block that makes this pretty easy to see. Let's go with this terracotta. So I've got that set here. And then what I'm going to do is go to the opposite corner and mark it as well, which is right there. That lines up with that, but keep in mind that we have a couple of things. There is actually redstone sitting on top of this block right here. So we actually have this level here, 1, 2, and 3. That's what we need to copy. There's nothing under. In this case, you didn't see we don't have any tunnels or anything. So we need to do one more here like this. So we can check out the width and the height of our circuit by simply doing this now. You want to pop up the F3. You want to point at this, and you want to look over here for a targeted block, and you will see its actual coordinates of that target. So that is one corner of the block, and so there we have negative 37, 14 for the up-down dimension, the green one that you see marked here, and 128 for the Y. So you can think about this any way you want it. And then we do the same thing over here. So we're going to go to this block, then target it, and you'll see that we are now at negative 22, 17, and 142. Now recall that you always want to copy from the lowest number to the highest number. And so if we look at these coordinates, 37, 14, 128 for one, and 22, 17, 142 for another. What we really want to do is we're going to copy from negative 22, take the 14, into 128. Now where is that going to be, you might ask yourself. Well, if you remember, you come over here. And then we always want to copy to the highest version. So I've got negative 22, 14, and 128. Which we can find fairly easy. Negative 22 is over here. So here we have negative 22, 14, and 128. That is the what you might call the left closest corner. And if we go to the opposite corner, we do the same thing we did here. Line this up and go. That gets us to that level. And we have to go one more because you have redstone sitting on top of that block. And if you look here, you have some negative 37, 17, and 142. So those are the two corners we're going to copy. Now the question that you always have to ask, and you have to remember this as you're doing these copying, these cloning operations. Which square do I start on? Which way does it copy? Well, that's pretty easy to see. So what we're going to do is we're going to move over here quite a ways. We have plenty of room. And move forward so we don't damage anything. And then we bring up that clone command by hitting slash. And I'm going to say clone. And we start with our negative 22, 14, 128. You see that's the beginning block. If you come back here, you'll see that where do I begin and where do I end? And I end right here at negative 37, 17, 142. Where do I want to put it? Well, that depends on exactly where I want it. I think I want to put it right at my target block, which right in front of me. You see that's over here. It's negative 13, 14, 151. I'll shoot a trick later about that. Another time, and then we just hit enter. And you can see that it copied from this corner, not that corner where we were standing. So that's definitely an important thing to know. So it's going to start here, then copy that way. As you can see, that moves from the I direction to here. We're adding 1, 13 to make it 12 to 11, and then you can also see that we then start adding in this direction. We're adding 1 as well, and then it rises up as we go. The way Minecraft copies it starts at your starting point, and whatever that is, and then it adds 1 in every direction to the copy. So we want to start at this corner. So now that we know that this is the corner that the copy to, we can decide again that we want to put that, and maybe we want to line it up with this one. Now here's the trick. You can see that my targeted block over here is negative 37, 14, 147. But the other thing that I can do is I can put it in my current copy. So I'm going to stand on that block. And you look over here and see that my location over here at block is also negative 37, 15, 148. And then when I pop up the clone command, on the up arrow, I'm going to take this off. Instead, I'm going to use this notation. Tilde, tilde, tilde. And you can see that it built it right on top of where I was standing. Just like that. So that's a shorthand. So what you really want to do is you come down here and you stand, because we're copying this where you want it. We want it on the bottom. So you always make a hole where you're at. And then I'm going to pop up that same clone command. I'm staying in a different place, and I hit enter here. And you'll see that we've actually copied and cloned that information perfectly. So that's all we have to do. If we want a JK Flipflop over here, we're going to start it right here. It's going to extend in that direction. I'm going to start it right here. So remember, I go down. I'm pointing at the block that I want. I stand in it, into my hole, and I pop up that exact same clone command. I'm not changing where I'm copying from. It's just this is the beginning, this is the end of where I'm going. I hit enter here. I've got my JK Flipflop sitting right here. You can see it's got all the blocks that I put in there. If you remember, this is our input right here. So let's bring our clock over here. Keeping in mind at some point we're going to have to add a repeater. Looks like that repeater's going to be right there. I think I'll bring it over one here. And you'll see my repeater's going to go right there. So I need a repeater. Drop it off, and then we're going to connect. Let's see what happens with our JK Flipflop this way. There's the clock. And as you see, our timing is off because the clock is too slow. now we look over here, and you can see it's still too slow. Well, we can hear our pulse coming right here. So this is clock on, and it toggles a couple times, and you see it's not actually toggling. My clock is still, it's still too slow. So turn it off. And we have 3. I'm going to put 2 in, and we'll turn it back on and see if this works. So pulse, 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 pulse. So now our JK Flipflop is working. It looks like our clock is timed properly for our JK Flipflop. As this line powers here, you can see it toggles for every clock cycle. On, off, on, off, on, off, on, off. And that's fine and dandy with our clock running here. But the problem with that is we want one clock for all circuits. And if I have a great big long circuit, that could become a real problem. So let me go back and say, you know, maybe we do have a slower clock. Maybe we're operating like this. So the question is, oh, it's firing. You see the clock's on. It's off. Oh, in fact, this particular clock is going to always cause a problem because it's causing our circuit to burn out. So clock on, and the circuit starts firing, but when it stops, we're in the wrong state, and it's destroyed. So the question is, how can we limit this pulse and get it to go faster? There are a couple different ways to do that, and that is called the Monostable Circuit. Okay, one of the ways to do the Monostable Circuit is to split this like this. Then we're going to put an inverter here. A chunk of wire here. We're going to build an AND gate across this. It looks like it's like this. We put torches here, and there, and there. And just make this simple and use it that way. And then we put wire across here. So now what this does is, you get a signal that goes faster through here and slower through here. And so if we look at a pulse here, look how short this is. Here comes the rising edge in a little bit, and watch what happens in this location here. So here's the rising edge. When that turns on, when the clock moves over, watch what happens here. Oh, it's very short. And so what we have is, even though we have a long pulse over here from the input, you get a very short one there. Now we're going to watch what happens. Here comes our input. Coming on. The question is, does it work? And the answer is no. You can see that it's not toggling. And so this is the reason. Now this in using real circuits, doing an AND gate with an inverter and the uninverted signal was a way to achieve a monostable circuit when on. So in other words, I want to keep the pulse as short as possible. But you see, I can't adjust this. There's no way for me to actually get it. I actually need a shorter pulse to operate here. Now we know we've already talked about it's possible for me, for instance, so maybe I'll go in and I'll delay this. And maybe that's going to be enough of a delay that it works. Still not. Maybe add that last chunk of delay. Let's see if that's enough. No, it is not. We have the same problem we had. Put this down for a sec to reset the circuit. as you can still see that it's a very fast, this JK Flipflop is very fast, so we haven't managed to slow it down enough. Now, it's only a repeater we can mess with there. I can turn it back to the fastest, and we'll see what happens. And once again, it doesn't work. So this is why this is not the best monostable circuit. Now, using real electronics, we actually have a device that would do this for us. It would shorten this fault to make it, but in Minecraft, we have to be a little more creative. And if you look at various monostable circuits, there's a couple different ways to do this. And we will work on our first one. So I'm going to go ahead and get rid of this. And we're going to see what other ways we can come up with eliminating this. So we're going to come off that repeater right there. And I'm going to add a block. You can see if I put something back here, that block becomes on because this is weekly power. Now what I'm going to do is I'm going to put a dropper here. And the way that dropper faces, while I'm here, I'm also going to go ahead and get another hopper. So I'm going to put that dropper. You recall when you put a dropper, you put something in this dropper, like this. It receives a pulse. It fires that out. And so it goes into whatever is next. So what we're going to do is we're going to take all of this out. And I'm going to put a hopper on there by right-click and shift. I'm going to get that. Okay. So we'll put a light flashing into the comparator. And we want this comparator to be able to tell us when there's something in the hopper or not. The comparator faces away from the hopper. So we go like this. Let's put a light here. And now let's put something in here. Let's just do one. Now, look here over on the right, this is the incoming pulse from the clock, and this is the pulse right here. And what happens is, this dropper shoots the item into here. If you look here, you'll see it every once in a while. Or we see the item here. There it is. And that causes this thing to fire this and power this block. That's like a repeated stronger power, so I can actually bring, for instance, my wire out of this. So, but as you can see, it's very weak. Now I get one coming out of that. And that is because there's not very many items in this. You might think, well, I just put more items in here. The problem is the comparator is going to say how many items are in the hopper. The reality is there's only one item in the hopper. I guess we're going to do, you guessed it, the repeater right here. And now we get a repeater into our device. We can adjust this if we need to, but if you look now, I'll go back here where we can see the incoming clock pulse. And you can see that the clock pulse goes from here. It's now in the off state. It'll be coming on, rising edge is coming. And every time that clock pulses, we want this JK to flip-flop. So here's the pulse. You can see it flops over to here, and then goes off. Next, rising edge is there, circuit operates, and so now we've solved the problem. So using this device, we've come up with a way to create a monostable circuit. It's a block going into a dropper, going into a hopper, with a comparator going to a repeater. So it's a 1 by 5, 1, 2, 3, 4, 5 blocks And what this is doing is solving our problem, as you can see right here. All the way back there, our clock is pulsing. We can make that pretty obvious by simply wait till it goes off. Now we can see that light is going to be our clock over here. And if you look over there, we have the JK Flipflop. We can see them both. Here it is. Clock on, toggle. Clock off, nothing happens. Clock on, toggle. You can now see, regardless of how long this incoming pulse is right here, it is only a very amount of length coming out of this other side. That's how our circuit works. That's a monostable circuit. Okay, so recall, we have built back here the type of clock that I can turn on or off using 2 hoppers, 2 comparators, 2 blocks, 2 pistons, and a redstone block. It is variable length because I can put whatever I want in here. You take some of these out. Now it's going to pulse a lot faster. You can see our flip-flop's going to operate more. But you see this pulse is the same. Doesn't matter. Always the same length. And you'll notice it only fires on the rising edge, not the trailing edge. So this is a rising edge device. So there you have it, a clock. A monostable circuit that wants to stay off. It pulses and limits this pulse to a certain amount of time, which lets our JK flip-flop operate. That is where we are with MMC 12. If you like what you see, please give me the likes and subscribe so you get more. This is where we're actually going to start building the circuit. Our next one, we will actually build a binary display. Now, it's pretty easy to display binary, but we're going to do something a little bit fancier, and I think you'll like it. So tune in next time for MMC 13 when we talk about our binary display using what we have learned so far. Keep on learning. This is Imroy, out.